If I have a function y equals 2x, the derivative is 2. If I have my function y equals 2x plus 3, then derivative is still 2. If I write like y equals 2x plus c, then the derivative will be 2. Now the question is, what is the antiderivative of 2? We have seen 2 is the derivative of these three functions. So then antiderivative of 2 must be either 2x or 2x plus 3 or 2x plus c. So then the idea is like this. Antiderivative, you write like this, 2dx. Then your answer is coming out as 2x. And then if you add a constant c, or if you add a constant 3, or if you add any constant, nothing wrong. But when I add this 10 or this 3, these are particular when some conditions are given. But then when I ask you a question that what is the antiderivative of a given function, then if you take the antiderivative with the normal rule like this, you got your answer. Then you can add any constant unless there is any constant added and you are asked not to add. Suppose I have a question. This asking find the most general antiderivative of the function f of x equals 3 over square root of x plus 2. And then write your answer inside the box. And the constant c is already added. So in your answer, you don't add additional constant. So first look at your function. F of x is 3x to the negative half plus 2. Now when you take the antiderivative, negative half plus 2 dx, you are doing simply like 3x to the negative half plus 1, negative half plus 1 plus, there is a free constant, so multiply with x. Now when you further simplify, you get 1 half plus 1 in the denominator will be half. So you get 3x to the half over half plus 2x. Further if you simplify, you'll get it 6 square root of x, or you can say x to the half, either way you write. So I'm giving you 6 x to the half plus 2x. So that answer you can write here. 6x to the half plus 2x, and you are done. Next problem. I have a function f of x is cube root of x squared plus 1 over cube root of x. So let us look at the exponent on each term. So first I have x to the 2/3 plus x to the negative 1/3. Now when I take the antiderivative of the function, that means these terms, so this will give me x to the 2/3 plus 1, 2/3 plus 1 plus x to the negative 1/3 plus 1, negative 1/3 plus 1. Now if you are good in simplifying fractions, then you can do it faster. So 2/3 plus 1 will give you 5/3, and it is in the denominator, so then this will become 3 over 5, x to the 5 over 3 plus this one will give you 2/3, so then it will be 3 over 2, and then x to the 2 over 3, and then you put this answer here, 3 over 5 x to the 5 over 3 plus 3 over 2 x to the 2/3, and you are done. So our next problem is to find the antiderivative of f of x equals 5x minus x squared e to the x all over x squared. So first let us do the simplification on the function. So you have f of x equals, if you distribute x squared, then you get 5 over x minus e to the x. You can write like this, or you can say like this. Dx 1 over x will give you natural log. Careful with your absolute value sign. Without absolute value sign, you will have domain error and answer will not be accepted. Then you have e to the x. Now we are asking an antiderivative. If you add a constant, it's fine. If you don't add a constant, still it is fine. So, but I will add a constant, and we do not have any constant outside. So then I write natural log absolute x minus e to the x plus a c, and we are done. You may see some problem written like find the antiderivative for dx dt, which is 5t to the negative 1 plus 1, or it could be written 5 over t plus 1. So then when you take the antiderivative of this one, so from here you will get, you can write like this, so that dx equals 5 over t plus 1 dt. You can multiply both sides by dt and then take the antiderivative. Now this one, you know, integral dx is just x, and then this one will give you 5 natural log of t plus t, because one will give you t, and add a constant, or you don't have to because I have already constant there. So when you write your answer, carefully write 5 natural log of t absolute here plus t, and you are done for this.